So with simplifying, we want to put things together that we can put together. And in the mathematics, just like saying 3 apples and 2 oranges, you can't say you have 5 apple oranges. You have to only add things that are alike. Things are alike if they have the same variables with the same exponents. So in this one, it has 3 terms right now. I look, this one has an x, this one has an x, this one has an x. And I like to use something to indicate that they're alike. So this time I underlined all 3 of them because they're all 3 alike terms. And then if they are alike, you say, I have 7 x's, and I take away 5 x's. Well, 7 subtract 5 would give me 2, and then I add 1 more x. That would give me 3, and we write our answer by saying we have 3 of them. What do we have 3 of? We have 3 x's. So we always write the number that we would get, and then what we were counting, in this case, x's. So in part B, okay, we have to check, is there anything alike with an AB? Well, I look at the second one. It also has an A. It also has a B. The exponents are the same. So I'm going to say those 2 are the same. Then you just think about your numbers. If you're at 5 and you subtract 8, where would you be on your number line? You'd be at -3. And it would be -3AB. Y plus y plus y plus 3y. We notice this, 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 and this are all y's. How many would you have if you went 1 plus 1 plus 1 plus 3? 6y. Excellent. This is our first example that not everything's the same. Okay? In this first term, I've got a b. Are there any other terms that have a b? 5b. So I'm going to put, those 2 are going to be put together. I'm going to change my color pen here. This is just a regular number. Do we have any other just regular numbers? We have a 1 there. So notice in my indication here, I underlined some like terms, like the b's in blue. They're the same. And I underlined the numbers with squiggly to say those are the same. So I can put the blue ones together. If you have 2b and you subtract 5b, where on your number line would you be? 2 subtract 5. So we'd be at -3b's. Now we go to the ones that are underlined in green. If you have a -3 and you add 1, where would you end up? -2. So this is the first one that has 2 different things to do. Okay? So if we're following along on this one, okay, one of the things you want to try to do is, as you're listening, you want to see if you can answer in your head before I answer it, and then write things down and pay attention to that as we go. Okay. First term has an x. Are there any other ones with just an x? 6x. Perfect. I'll underline that in blue. Next one is the 3y. That's different, so I'll squiggle line it in green. Any other ones have just y? Yes. So now, if you have a -x and you add 6 x's on your number line, where would you be? If you're at -1, okay, if I draw it out, here's my number line. Here's -1. This is where I'm starting. Okay? And I'm adding 6 to it. So adding goes which direction? Forward to the right. I need to add 6. Where would I end up? +5. So if I have a -x plus 6x, I'm going to end at 5x. If I'm at -3 on my number line and I add 1, where would I be? at negative 2. So the idea of recognizing which ones are alike, that's new. It's not really new because you recognized apples were apples and oranges were oranges from a very young age. So you are able to recognize when things are alike and not alike easily. Okay? The adding and subtracting, that's the same adding and subtracting you've been doing for the last 3 years. So once you realize those two things are just put together in an algebra expression, the algebra itself isn't that bad. Okay? But it is paying attention to those details that is going to help you. Okay, next example. I'm going to underline the 4x squared in blue. Can I underline the other one in blue? It's got an x, but the exponent is different. So I have to underline the other one in green. They're not the same. All I can do is write 4x squared minus 3x cubed. Nothing can be done in that one. Okay, last one. Last one has an x squared and a y. Does this one have an x squared and a y? No. Does this one have an x squared and a y? Yes. So underline that one in blue. This one is different. So now we're going to put the blue ones together. We have negative 2, and we subtract 4 more. Where are you going to end on your number line? Negative 6. So I'd have negative 6 x squared y. The green one, there's just one green one. It's still going to be there all by itself, plus 3xy. Here's a new word for you. Well, maybe not. A word you've seen before, but I'm going to check to see, do we remember what perimeter means? Because we want to write a simplified expression for the perimeter. What does perimeter mean? It's the distance around an object. Okay? In Winnipeg, we have a perimeter highway, right? Because it sort of goes around the whole city. And that's why it was called the perimeter highway. And so if you want to find the perimeter, all you need to do is add up this side plus this side plus this side plus this side. So if I wanted to write that out, my perimeter would equal this side, x plus 10, plus this side, 8x minus 3, plus this side, 5x plus 1, plus this side, x minus 6. And sometimes, I'm going to do them in green. Sometimes teachers will put, or students will put brackets around each one separately so that you can really see you're adding one plus the next one plus the next one plus the next one. I'm going to take out my black pen. I have an x. Are there any other terms with x's? Yes, I've got an 8x, a 5x, and an xx. Then I've got a regular number 10. Do I have any other regular numbers? I have a minus 3. I have a plus 1. I have a minus 6. So when we go to write the perimeter of this one, how many x's do we have? I look at my ones that are underlined in black. If you have 1x and you add 8x, where would you be on your number line? 9. And then you add 5. 14. And then you add 1. 15. So we would write 15 x's. If you think about the numbers, you're starting with 10. Subtract 3. Where would we be? Starting at 10. Subtract 3. 7. Add 1. 8. Subtract 6. Okay, we'll start again. We're at 10. Subtract 3. Add 1. 8. Subtract 6. Sorry? We're at 8. We got to 8 here, and you take away 6 on your number line, where would you be? Sorry? We're subtracting 6. Right? You're at 8. Here's your number line. You're at 8. Subtracting would go this way, back 6. And you'd get 2. 2. So our simplified expression here is 15x plus 2. Okay? Now, if you had a calculator, if you were unsure about the math, you want to do it on your calculator, you could do on your calculator the 10 minus 3 plus the 1 minus 6 and push enter. One more example to do. This one's a little bit more involved because two sides aren't labeled. So we want to find the perimeter of this one. We have to figure out how long this blue side is and how long this green side is before we can add up all the sides. I'm going to tell you, I think the green one's easier to figure out. Anybody have any strategies for figuring out how long that green side is? Okay. So it looks like it's half of the 3 by visual. Now I'll tell you, on a math test or on a math thing, they don't always draw things accurately. So you can't just say it looks like to get your answer. There's got to be a math way to do it. And this one, it's not going to be half of 3, even though it looks like it's drawn that way. But there's another hint there to figure it out. It would just be x. What was it? What did you do to figure that out? Okay, so you went by visual again? Yeah. So that again isn't going to be a right reason to do it. Just looking at something, because he looked at it and said half 1.5, you looked at it and said x, you would be lucky because you got it right and he'd be unlucky, but that strategy isn't what's going to help us. Okay? What we're going to notice, does it make sense that this whole side is 3x? So that means if I started here and went all the way down to here, it should be 3x. How long is this dotted part? The same as this. Does it make sense that this dotted part would be 2x? And then what would you need to get 3? 1 more x. So let's see if you can use that idea to help us figure out the blue one. Okay, this whole length is 4x minus 1. What would have to be here? What would have to be here so that if you added, this is an x, plus this has to equal 4x minus 1? There would be 3 x's, but if I add 3x plus x, I get 4x. What would also have to be here so that if I added them, I get 4x minus 1? A minus 1. Does that make sense? And now we can say our perimeter will be equal to, add them all up, x. I'm going to start at the top, plus, and go around clockwise. X plus 3x minus 1 plus 2x plus 4x minus 1 plus 3x. Like terms, I'm going to underline the x ones in black. Whew, we got a lot of them. All right. Picking new people this time. Starting here. Carly, 1 plus 1. 2. Bobby, plus 3. 5. Perfect. Caden, plus 2. 7. Jacoby, we're at 7, plus 4. 11. And Luke, plus 3. 14. So we're going to get 14 x's. Now let's look at the numbers. Where do we have numbers? We have a number here and here. The nice thing about underlining them with different things is that when you're done, everything should be underlined for you to write something down, right? Otherwise, you're forgetting something. So we only have two numbers here, -1, -1. -2. Perfect. Next thing I'm going to get you to do is at the bottom of your page, it says homework. Write this in there at that place.